Hi guys, am I live? Hi, is anyone there? Am I audible? Anyone there? Okay, let me just wait for a few viewers and then I will begin. I'm sorry guys, I'm sorry we had to fix this problem. Okay, let me just wait for a few of you to come in the live and then we will begin. It was going so good and then I messed it up, guys. Okay, basically this video is just a continuation of our previous video where we were solving the MIT integration bit 125 regular season problems, right? And yeah, like in our previous video, we did 17 problems and we did 16th problem. We were on the 17th problem right now, as you can see it in this file. We were on this problem and then I had some, I don't know, technical problems and then I got disconnected. So I'm doing it again. So I'm just waiting for one of you to respond in the chat so that I can begin. There are actually just two of you right now. If one of you can you please say that yeah it's going. I mean it's yeah let's go. Yeah, okay, let's go. Okay, good. Yeah. Okay, the thing was what we were doing was we first laid the function, this intra function as y, and then we noticed that this lower half was also y, so it becomes y equals to square root of x plus 1 over y, and then yeah, after that it was y square is equals to x plus 1 over y, and then y cube is equals to xy plus 1, and then y cube minus xy minus 1 is equals to 0, right? And now we were trying to use the cubic formula, and I was just trying to like Google the cubic formula, and then suddenly I had some power cut. I didn't know. I mean, some problems. So let me solve in the cubic formula now. Like this is the easier cubic formula. So if you have x cube plus px plus q is equals to 0, and now our x would just be cube root of negative q over 2 plus square root of uh, q over 2 square plus p over 3 cube, right? And then plus cube root of negative q over 2, the same expression with negative sign, square root of q over 2 square plus p over 3 cube. This is our cubic formula and this will make our life easier now, right? Okay, so if this is the first time seeing cubic formula, like I think you guys need to remember this because this is gonna be helpful a lot of the times, right? So now our expression becomes, we know that in this case our p is just negative x, q is just negative 1, right? Q is just negative 1, right? So our y becomes cube root of, our q is just negative 1, so that's half plus square root of half plus x cubed by 3, right? Do you think it's really worth it? Because what I'm trying to see is that why am I feeling like it's not going to work actually? Why do I have this feeling that it's not going to work? Because it's too hard, right? Okay, and then plus cube root of 1 over 2 minus square root of 1 over 2 plus x cubed by 3. So we do get this, but I didn't really feel that this is the way they wanted us to do. Hmm. Guys, so there's some other ways. I think this is getting too hard. I mean this is not really solvable. I don't know. How would I even solve it? Suzal, do you see any way like to solve this problem now? Do you? Suzal, do you see any ways I can solve this problem? Hmm. This doesn't really seem like it's simplifying. Can I do this? The root of x divided. I think this is similar. The thing is, yeah, I think yes, I know this is same, right? And I know that now I just need to integrate this expression from 0 to 7 over 2 of this expression. I don't know that, right? Because this is like this is exactly same. I know that. But how do I even integrate this? This looks so tough, right? Yeah. Now how do I even integrate this? You may get pattern. Hmm. I may get pattern. Let me see. Guys, this is hard. Guys, let me. Well, is it really that? I think the first expression should not have a square, but it has. It has. I cannot do anything. Um. mm, Oh, how do I do this? The third person who just joined, can you suggest some ways to solve this problem? The problem is actually this one, and we were just trying to simplify it, right? You might see what we're trying to do. If you have any ideas, please do suggest. I would really appreciate that. Oh, the fourth one again. The fourth one who just joined, can you please suggest us some ways or some ideas to solve this? We are stuck. Oh, he just left. Okay, that's fine. Suzal, do you see any pattern? Like, can you try to find some pattern? Is there any pat? I mean, how do I try this now? I don't see any ways. I don't see any ways now. Okay, so yeah, okay. X is equals to y by 3y minus 1. X is equals to y by y 3 minus 1. I didn't get it. Like, can you a bit write more clearly? X is equals to y by 3y minus 1. Okay, so x is equals to y by 3y minus 1. How will it work? Oh, I'm not getting what you're trying to say, Susan. Why by 3 How will it work? Hmm. No idea. No idea. Getting that. Is there any other way? Are there any other ways? Okay. X is equals to y cubed by y minus 1. X is equals to y cubed by y minus 1. Oh, I see what you mean. But like expressing x in terms of y, how will that be helpful to us? So I see what you mean. You mean that y cube minus 1 by y is x, right? From here. But how is it helpful? Oh, I think there's some. I'm not sure though. Oh, I think there's some way. I think this should be helpful to us. Okay. Let's go this way. Let's go this way. We now at least know that we actually okay. So we actually want to find integral from 0 to 7 by 2 of y times dx, right? This is dx, right? And we know that x is equals to y cube minus 1 by y, right? Oh yeah. I think you're right. Yeah. And now, instead of trying to find y instead of x, let's try to find dx. And also, let's also know that these limits of integral are in the world of x. Okay. Yeah, I think we should not forget that, right? These limits of integral are in the world of x. Okay. So now So now this dx will just be y times 3y square minus y cube minus 1 times y by y square. Right? So dx will basically be 3y cube minus y cube plus 1, right? And then by y square times dy. So our dx is basically just uh, 2y cube plus 1 by y square dy, right? So we got dx in terms of dy. Now regarding the limits of integral, now notice that over here where there's x is y cube minus 1 by y, when y is 2, x is exactly 8 minus 1 by 2, which is 7 by 2, right? And when y is 1, x is exactly 1 minus 1 by 1, which is 0. So that means when x is 0 and 7 by 2, y should be 1 to 2. So this should go from 1 to 2 of y, and then dx should be this expression uh, 2y cube plus 1 by y square. Wow, that's awesome, Sizzle. You are awesome. That really worked. Like, uh, what do you say? Like, shout out to Swizzle for this problem, for this solution, right? Yeah. Oh, there's some. Okay, I need to do it fast now. So this is y times 3y square minus y cube minus 1 by y square. Then this 3y cube minus y cube plus 1. Yeah, okay, now it's all good. So now this becomes 1 to 2. And then 2y cube plus 1 by y dy. So this becomes 1 to 2y square plus 1 by y dy, and then now this becomes 2 times y cubed by 3 plus ln of y from 1 to 2, Now this becomes 2 by 3. 2 cube minus 1 cube is 7 plus ln of 2 minus ln of 1 is just ln of 2. So that's 14 by 3 plus ln of 2. That's a beautiful solution. Susan, the Suzal. That is so nice. That is so awesome problem. Now I will. Now I have one more tool set with me. Like yeah, I also have this formula as well as I also have this new idea. Like this is the first time I don't know. Like I had tried this before. Like such I don't know. Maybe I had, but I forgot. Okay. So and the answer. Let us take the answer first. 14 by 3 plus ln of 2. 14 by 3 plus yeah, exactly, and that's so much fun when you see that answer is correct, right? Let's go to the next one. Let's go to the 18th problem. We don't have my battery is draining. 0 to infinity x plus 1 to the power 4 to the power negative x squared dx. This is this 18th problem. 0 to infinity x plus 1 to the power 4 to the power negative x squared dx. 0 to infinity x plus 1 to the power 4 to the power negative x squared dx, right? Is that it? 0 to infinity x plus 1 to the power 4 to the power negative x squared dx. Okay. Like as always, I first want you guys to give me some ideas, and then we will go on exploring the ideas and then see if it works or not. I will also try to get some ideas from my side, but I would really appreciate if you guys can give me the ideas, right? We're trying to engage, right? So, guys, do you think that I should try some sort of gamma function in this integral? Oh, y is equals to okay. Integration by parts can be okay. Okay, let's go with what we're okay. Huh? Y equals to x square. Hmm. I don't think because if I do that, I will over here have y to the power half. And I think that even complicates the problem. Right? Yeah. So instead, I think I should do is let me substitute. No. Okay. Mm. So what's our gamma function? Our gamma function is that in range from 0 to infinity, e to the power minus uh, x to the power, sorry, e to the power minus t to the power x minus 1, dx is just gamma of x, right? And gamma of x is just x minus 1 factorial. I guess you guys, I think you guys should know this if you are going for integration b, right? This beta gamma function, that's helpful. Okay. So now x minus 1 factorial. Now that if we know this, how we can use it? The thing is, if I use it, the limits of integration will get messed up. So then that's a problem. Okay, now how I'm gonna do is I'm gonna do different, slightly different this time. So let me write this as a binomial sum. Sum from n equals to 0 to 4. Like, sorry, let me write it as k, or let's say n is fine. N equals 0 to 4. 4cn x to the power n. Let me write it this way. I'm trying something new this time, right? Now let me integrate in the sum and integral. I can do that. 0 to infinity. And again, sorry, this is sum is from 0 to 4. And I think that, oh yeah, exactly, Suzal. I'm doing the same thing. So from 0 to infinity, 4cn x to the power n e to the power minus x squared dx, right? So sum from n equals to 0 to 4, 4cn Now I can actually use the gamma function that I'm trying to use, that I'm so desperate for. If I make a substitution that y is equals to x square, I will have y to the power half is equals to x, and then I will have half y to the power minus half dy is equals to dx. If I use that, I will have sum from n equals to 0 to 4, 4cn integral from 0 to infinity again, and now this becomes y to the power n by 2, right? This will be to the power minus y, and dx becomes half y to the power minus half dy, right? So now I can take half outside. Sum from n equals to 0 to 4, 4cn integral from 0 to infinity. This is e to the power minus y, y to the power, this is n minus 1 by 2 dy, right? Now this becomes half, sum from n equals to 0 to 4, 4cn. Now this is just gamma of this expression plus 1, right? So 1 by 4, sum from n equals to 0 to 4, 4cn, gamma of n plus 1 over 2, right? Okay, now this evaluates to 1 over 2, 4c0, gamma of half, plus 4c1, gamma of 1, plus 4c2, gamma of 3 by 2, plus 4c3, gamma of 2, plus 4c4, gamma of 5 over 2, right? Now we know that 4c0 is just 1, gamma of half is root pi, 4c1 is 4, gamma of 1 is just 1, plus 4c2 is 6, gamma of 3 by 2 is just root pi by 2, 4c3 is 4, gamma of 2 is 1 again, 4c4 is 1, gamma of 5 by 2 is 3 by 4 times root pi. Using this, yeah, definitely I'm assuming that you know gamma function, right? So root pi 1 plus, oh, I cannot take root pi common because not every term has root pi. So again, let's add the terms to the root pi plus 3 root pi plus 3 by 4 root pi plus 4 plus 4. Now this becomes 1 by 2. Now this is 19 by 4 root pi, right? Plus 8, and that gives us 19 by 8 root pi plus 4. And that's, I didn't understand how you use gamma. Okay, so which step? I mean, okay, okay, over here. Okay, I mean, from where should I explain it? Like, I mean, from where? From which part? Okay, so this is the definition of gamma function, right? The definition of gamma function is integral from 0 to infinity e to the power minus t to the power x minus 1. What is gamma function? How to use it? Oh, I'll just give a slight intro because, okay, I'll just give a slight intro. Okay, thing is, basically, gamma function is just an expansion of the factorial function, right? For all real numbers, because the factorial is only for integers, right? But gamma function is an extension for all real numbers. For integer, it does behave like the factorial, but for other numbers, it behaves slightly differently, right? And like, there's an integral form for the gamma function, right? So integral from 0 to infinity e to the power minus t times t to the power x minus 1 dt, right? Oh, but here it's dt, I'm sorry, it's dt. Okay, now let me show you some examples that might clarify. Okay, the thing is, let's say if I want to take this integral to the power integral from 0 to infinity t to the power e to the power minus t to the power, let's say, 2 dt. This is actually gamma of 3, there are also 2 factorial, right? Similarly, if you try to evaluate, you will see that if you use integration by parts, you will see that it's 2 factorial. Similarly, if you try to evaluate this e to the power minus t to the power 10 dt, if you try to evaluate this using integration by parts, the answer is 10 factorial, or also gamma of 11, right? So gamma is just defined as, like, if, yeah, for x factorial, gamma is just x plus, I mean, yeah, it's defined this way. Like, it's just, there's just the argument of gamma is one more than the factorial. And yeah, similarly, if you now, since this integral can be taken for any number, right? For any x, you can find the integral. So that's how we see that if we try to find gamma of half, we try to evaluate this integral, e to the power minus t, d to the power minus half, right? Half minus 1 is here. Uh, yeah, dt, if we try to evaluate this, you get root pi, and that's also supposed to be our minus half factorial, right? Yeah. So basically, gamma function expands the factorial to any real numbers using this integral definition. Are you getting it? So yeah, since we have an integral definition for factorial, we can expand the gamma function to any real number. Similarly, gamma of 3 by 2, if we try to find it using this integral, that t to the power half dt, you get root pi over 2. And also, this is also the half factorial, right? And also, you can actually get this result using the fact that, like, n factorial is n times n minus 1 factorial, right? You can use this formula, so that half factorial becomes half times half minus 1 factorial. So this is just half times negative half factorial, and negative half is factorial is root pi, so that becomes half into root pi, root pi by 2, right? So yeah, this is how you can find, let's say if you want to find value for now 3 by 2 factorial, you can again do the same thing. 3 by 2 times half factorial, right? Because I'm subtracting 1 from 3 by 2. And half factorial root pi by 2, so that becomes 3 by 4 times root pi. This is how I got the values. Hello, epic name, the epic name. Hi. So yeah, that's how I found gamma 5 by 2, and then this was our gamma 3 by 2, that is our gamma 1 by 2. Gamma 2 is easy because that's just 1 factorial, which is 1. Gamma 3 is also easy because that's just 2 factorial, which is 2. Yeah, so that's how I did it now. And after I had the gamma, I just used these values and I got the answer. So hopefully this should clarify you. Like, I think after this session you might again wanna watch this clip where I explain the gamma function again in repeat, and then I think that should make it more clear to you. Also, I already have a lot of videos in gamma function on my channel. You can watch them, right? I have solved a lot of integrals using gamma functions, so I think that should help you, right? Also, there are a lot of videos on YouTube as well. Okay, yeah, okay. Since I got the law of reaction, I think I'm good to go. So yeah, now let's go ahead. Yeah, the answer is right. No, yeah, 4 plus 19 by 8 root pi, exactly what we found out. Now, the 19th problem. Woo, this is interesting. Cos 3x, cos 5x, cos 7x from 0 to pi by 2. Okay, now the 19th problem of MIT integration B, from 0 to pi by 2. The integral is, what is it? It's cos 3x, cos 5x, cos 7x. Cos 3x, cos 5x, cos 7x. Okay, now, like, just like always, now how do we approach this problem? Using cos C cos D formula. I can do that. First 3x and 7x to get 5x. Okay, I can do that. Oh, but it seems like that would be so long, right? That's boring. Isn't there any other way? Do you think there's some other way to solve this problem? Okay, let's go with that. That's simple. Okay, let's go with that. So the integral from 0 to pi by 2, right? Now if we try to convert this product to sum, that becomes cos of 10x. You don't get 5x, like you just get 10x. You just have to add it. Like like we are not how, I mean, while changing from sum to product, we divide by 2, but from product to sum, we just add it. So there's no 5x. I'm sorry for that. Okay, now this is cos of 4x by 2, right? Basically 7x minus 3x and 7x plus 3x times cos 5x dx, right? So now this is now 0 to pi by 2 cos 10x cos 5x plus cos 4x cos 5x over 2 dx, right? Okay, so now this is integration from 0 to pi by 2. Again, this becomes cos of 15x plus cos of 5x by 2 plus, now this becomes cos of 9x plus cos of x by 2. Basically, I'm taking the sum and the difference, right? Now this is simple actually. From 0 to pi by 2, this becomes cos of 15x plus cos of 5x plus cos of 9x plus cos of x divided by 4 dx, right? After that, I can just integrate. This is so easy actually. 1 by 4. Now this becomes sine of 15x over 15 plus sine of 5x over 5 plus sine of 9x over 9 plus sine of x, 0 to pi by 2. And again, just like previously, we need to know, like it's like if it's like, okay, first of all let me evaluate this. So 1 by 4. Now here we get sine of 15 pi by 2, right? Now if it's pi by 2, 5 pi by 2, 9 pi by 2, 13 pi by 2, 17 pi by 2, the value is 1. But if we have, let's say, 3 pi by 2, 7 pi by 2, 11 pi by 2, 15 pi, sorry, 15 pi by 2, the value is -1, right? So yeah, we need to take care of that. So if we sine of 15 pi by 2 will just be -1, -1 by 15, and 5 pi by 2 is just 1, so 1 by 5, 9 also 1, so 1 by 9 plus 1 minus, at 0 all of this is 0. So we get 1 by 4 times, yeah, -1 by 15 plus, if we add them, LCM is 45, 9 plus 5 plus 45, right? And then 1 by 4, again LCM is 45. This over here, 45 plus 5 is 50, 59 minus 3. So that's 1 by 4 times 56 by 45, which is 14 by 45, and that's our answer. Whew. 14 by 45. Exactly, guys. So this wasn't anything more than trying to break a product into a sum, right? It's just so easy actually. So now let's go to the next problem. And this is our last problem, guys. This is our last problem, right? And we are done. All now we will finally done with the regular season of Hammer Integration B, and we solved all the problems using our collaboration. And yeah, okay, from -1 to 1. This is so easy, guys. Guys, I already know the answer, guys. I already know the answer to this problem. I was just looking. Okay. So question 20 is -1 to 1 e to the power 2x sine of sin h x dx. Okay, so how should we solve this problem, guys? I thought that I knew the answer, but I wasn't correct. So how should we solve the problem, guys? This one. So just me some ways to solve it. How would you solve it, guys? Give me your ways, give me your ideas. Epic Nam, the Epic Gamer, please give your ideas. Hmm. 0 minus 0. But how do you know that? I mean, okay, like this isn't really an odd function, because uh, the term sine of sinus x, this is odd, right? But this is neither odd nor even. So using the relation of sinus x with e to the power x. That can be helpful. But yeah, this is not really an odd function. It's of is eta is. I didn't understand. Okay, so okay, so do you think we should use? Okay, let us go with using the relation of sinus x with e to the power x. But that also looks complicated to me, guys. What about definition of sinus x? Yeah, we can definitely do that, guys. Okay, so definitely let's go with that then. All of you are suggesting the same thing. Okay, let's go with that. Minus 1 to 1 e to the power 2x sine of e to the power x minus e to the power minus x by 2, right? And now, should I make a substitution that e to the power x is just y? Hmm. Okay. So minus 1 to 1 e to the power 2x sine of e to the power 2x minus 1 by 2 times e to the power x dx, right? So if I substitute y as, I don't know, this isn't gonna be helpful, I guess. Let's just try. So e to the power minus 1 to e to the power 1, this is y square sine of y square. Oh, I need to do it fast. This is the last problem. I have battery of 5%. I need to make it by 2y dy. Now, now what? Now what? Oh, also, I forgot to make the. Okay, now our if that's the case, now x will just be ln of y, so dx will be 1 by y dy, and that's a good thing because now it simplifies to e to the power minus 1 to e y times sine of y square minus 1 by 2y. But now what? Again, now what? Is splitting it with a trig identity possible? I'm also trying to see that if it's possible to split it with some trig identities. Let's see if we can do that. Mm-mm-mm-mm-mm-mm. Okay, I don't know if this will be helpful or not, or am I just complicating? Let me see. If we substitute over here y as sec theta, This will be sec square theta minus 1 by 2 sec theta, which is tan square theta by 2 sec theta. Now that is sin square theta by cos square theta times 1 by 2 times cos theta, and that is just 1 by sec theta tan theta. How is that even helpful? How is that even helpful to us? I think there's some way. Okay, okay, let's do it this way. Okay. I think what I can do instead is, we know that sine 2x is equals to 2 sine x cos x, right? I'm not sure. Okay, and then divide by sine square x plus cos square x, and this becomes 2 tan x by 1 plus tan square x. It's not working, maths. If only clue were here. Guys, we definitely have clue. We can definitely check the answer if you want. Should I? Should I take? Oh, it's so long. Okay, this does give us the idea that we should. Okay, from here we get the idea that we should make a use substitution. That okay, okay. I'm sorry for checking the answer again, but yeah, now I get the idea how to solve it. Hmm. So from there, we just learned that we should make a substitution that we use, right? Am I correct? Yeah. Okay, let's make a substitution that u is sin x, right? And if I do that now, uh, how do I even write it by 2x? I make a substitution. We know that u is now. I don't know if that should work, but I don't know how it will. How will it work? By 2 times e to the power x, right? Hmm. My battery is now 4%, guys. Okay, with the trigger identity possible. Should you go with the previous idea or should you try this way? What did you do previously? What was the substitution that we made earlier? Oh, I cannot even undo more than this, guys. I'm trapped now. What did you do earlier? Uh, guys. Okay. How's your battery? Yeah, my battery, like, I mean, my battery in the tab is just 4%, right? Okay. Let me Google something first. Is there a formula for e to the power? Is there a formula for e to the power arc sine as x? If there is, then it will be easier for us. Okay. Oh no, wait. Oh yes, there's this formula, guys. Now it's gonna be easy. Wait. Now wait and see. It's gonna be easy now. Just wait and see. Just wait and see. Yeah. Okay. What we're gonna do is, yeah, we're gonna make the substitution, right? Now, um, we know that, okay, if this is the case, now du, okay, wait, if this is the case, now our du is just gonna be, I guess, cos x dx, right? Or also what I can do is, x is gonna be sine x inverse y, right? And also we know that Sin h inverse y can be written as ln of x plus square root of, sorry, sin h inverse u in this case. Sin h inverse u, this can be written as ln of u plus square root of, is it u square minus 1? Plus 1, I'm sorry. So u square plus 1. So there's this like inverse sine to log conversion. Yeah, there's this thing. Yeah, you can actually find it anywhere. And now if we use this, so now x becomes ln of u plus square root of u square plus 1, right? So dx will just be 1 by u plus square root of u square plus 1, right? And then this will be 1 plus 1 by 2 square root of u square plus 1 times du, right? Times like 2u times du. So dx will just be now 1 by u plus square root of u square plus 1 times, this cancels out. So this will be square root of u square plus 1 plus u du. And dx is just du. How is that possible? Wait. Again, what did I mess up? X is the sinus minus u. 1 by u, and then 1 plus 1 is 2u. Oh, wait. Okay, okay, over here. Okay. Now divide by root of u square. I forgot this one. So now dx is just 1 by square root of u square plus 1 du. Right? Okay, so now that we know this, and also now we know the fact that this over here, our x is the sin h inverse u, right? So sin h inverse u, right? And now we know that sin h inverse u is just ln of u plus square root of u square plus 1 times 2. So this becomes u plus square root of u square plus 1 square, right? And that becomes u square plus 2u square root of u square plus 1 plus u square plus 1. So that means 2u square plus 2u times square root of u square plus 1, right? And now this becomes, now if I'm making the substitution, now this is from sin h of minus 1 to sin h of 1, right? And e to the power 2x is just 2u square. Let me just write it in the simpler form for now. The form that is u plus square root of u square plus 1 square, right? And this is sine of u, and then dx is just 1 by square root of u square plus 1 du. And now what? Now what? Now what? This is no way gonna simplify now. Now we have the sine u. What was the answer? Sine of sine h1, cos of sine h1. Guys, let's just do integration by parts. I don't think this is gonna work. This is again a mess. Let's just do integration by parts, guys. Minus 1 to 1 e to the power 2x sine of sine h x dx, right? Minus 1 to 1 e to the power 2x, and okay. If you use integration by parts, let's say this is I. So I will be e to the power 2x as it is, and its derivative will just be cos of, sorry. First of all, sine of sine h x as it is, right? And this derivative in integral v to the power 2x by 2 minus, from minus 1 to 1, its derivative is now cos of cos h x, sorry, cos of sine h x times, and then it will be cos h x times e to the power mm, 2x by 2 dx, right? So I is sine of sine as x by to the power 2x by 2 minus half of integral from minus 1 to 1. So now this is cos of sine as x, cos as x e to the power 2x dx, right? Now what? Guys, now what? How is there no e in the solution? Like how in the solution there's no e? Mm-hmm. I'm so stuck right now. So okay, let me just go ahead. Let me just go ahead with what there is. I have no other way because I will try this until my iPad dies, and then and then if I am not able to do it, just know that I was not able to. So now I can break this, right? I can break this as e to the power x plus e to the power minus x by 2 e to the power 2x dx, right? So I is equals to sine of sine as x. But that's, I don't know, I don't think that's gonna help me. So into 1 cos of sine as x e to the power 3x. How is that even helpful to me? How is that even helpful to me? No. I can again increase my parts. Let me again do increase my parts. I have no other way. Wait. So I have sine of sine as x e to the power 2x by 2 minus 1 by 4. Now this will just be okay. Now I will differentiate. First of all, it will be as it is, right? E to the power 3x by 3 minus from minus 1 to 1. If I take the derivative, this will become plus sine of sine as x cos x e to the power 3x, right? Plus cos of sine x e to the power x. Now this will again become plus just like the other way. Sine of sine x and then cos x e to the power x, right? Okay, so now I have I as sine of take cos of sine x as d. Ooh, wow, that's a good idea. Okay, let me just do that instead of this right now. Okay, okay. So I'm trying to say into what are the minus 1 to 1 e to the power 2x sine of sine x, right? Okay, if I make the t as cos of sine x, or dt will just be negative sine of sine x times sine x, then this will be cos x, right? Now dt and the dx. Negative sine of sine x and cos x is, I mean, now how do I connect it? Cos x is, now this is e to the power 2x minus plus 1 by e to the power x. Now how do I connect that? Now, now this is the e to the power 2x plus 1 by 2 times e to the power x. But how do I now connect it? How do I proceed ahead? Now it's 2%. How do I go ahead, man? Like, how do you think I can solve this problem? Mm, 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 mm. Is there any way like that I can proceed ahead, or am I stuck over here? Adit, Samira, Sami, I don't know. I'm sorry. Is there any other? Is there? How do I proceed ahead now? Mhm. Okay, I'm not sure. Should be doing this. Mhm. Okay, seems like he isn't there. So let me do this. Let me go on with this way. I don't know. I'm just trying to see if it somehow cancels and manages to be get solved. I'm not sure though. Cos of sin x e to the power 3x by 3 minus 1 by 4. Cos of sin x e to the power x, and then again, we again just like previously, 1 by 4 from minus 1 to 1 sine of sin x. Now this just becomes e to the power 4x plus e to the power 2x by 2, right? Plus minus 1 to 1 sine of sin x e to the power 2x plus 1 by 2, right? Okay, now this becomes sine of sin x e to the power 2x by 2 minus 1 by 4 cos of sin x e to the power 3x by 3, and then minus 1 by 4 cos of sin x e to the power x, right? And then okay, now I have these integrals. 1 by minus 1 by 8 integral, all these integrals from minus 1 to 1 sine of sin x e to the power 4x minus 1 to 1 sine of sin x e to the power 2x minus 1 to 1 sine of sin x e to the power 2x minus 1 to 1 sine of sin x. Phew. So now the thing is that I'm trying to do is over here there was 2, right? So this one with power 2, this is so messed up actually. Guys, my battery is just 1% now. I'm not sure if I'll be able to solve this. Okay, now like I think this side there should be this some idea with this way. Okay, let's go with this way, but also let us try to introduce something more over here. Let's try to do something more so that we actually solve it. Math's not mathing right now. Okay, what about we just introduce it to the by x over here, but that won't work. Oh, guys, so there's something, guys. I just have a few seconds now, and I'm gonna go after that. So there's some. I mean, Adit, do you have like any way to continue this solution? Hey, Swizzle, like Swizzle, are you there? Like, help me. I need your help. Hmm. Swizzle, anyone, guys? Let me just try to decode from the answer again. Okay, there's this sign it, 1, cos of sin it, 1. How do I decode the how? Now only two of you are there. Guys, I think the best way is I will upload a video solving this problem on my channel. So that's it for today. And yeah, guys, I'll actually upload a video solving this because like there are no ideas are generating, and sometimes it's good to leave some problems open for solution. Right now, you guys might want to try this, and then yeah, guys, just try. Yeah, thank you so much.